Hi guys, welcome to my channel. So I want to look at this tutorial question. It's an arithmetic progression question. So the question is find the sum of AP, which is the arithmetic progression, and the values are 1, 3, 5 up to 101. So we are going to look for the for the arithmetic progression. Sorry. Okay, so what do we do here now? In order for us to solve this, we'll be presenting to us two formulae. Okay, so the first one we'll be looking at is what the sum of term. Sum of term equals to what number of term divided by 2. Okay, then we have what 2a, which is the first term, plus what n minus 1d. Okay, so this is the first formula for finding what sum of what an arithmetic progression. Okay, so the second one we'll be looking at is what the second formula is what n over 2. Then we have what a plus l. Okay, so this is the second formula. So depending on how the question comes, there are some times whereby the question will be we might not be given the last term, but we'll be given some other parameters. Okay, so let's now define what this term means. So we have this this to be what the sum of of terms. That's the sum of terms. That's what this means. Then we have the n, which is the number of terms. The number of terms, that's when you count them individually. That's the number. How many are they? Okay, then we have a, which is the which is the first term. Okay, then we have this already. Then d, we have d, which is what we call the common difference, which means the difference between the first term and the second term, and the difference between the second term and the third term, and so on and so forth. Okay, so that's the definition of the parameters we have for this first formula. Then looking at the second one, we still have the same thing here, which is this. We have n, which is this. We have a, which is this. But here we are now having l. So the l is the last term. That's the last term. Okay, so we are not having the no common difference here. What we have there is the last term. Okay, so now let's look at how we can do what we want to do. So for me, I will try, since I can use any of them, I can use any of these formula. So I would rather let me go with this. We can also use this and arrive at the same answer. So let's go with this, and because it is a kind of a is more compact than this. Okay, so let's look at what we have here. Let's put down all the parameters we have. Okay, so we want to look for this. So our n with the number of terms, we don't know it, so which is a question mark, which means we have to look for that the number of terms before we can say we want to find the sum of terms. Okay, the next thing we have there is a. So a, we come to this place. What's our first term? The first term there is is 1. Okay, so we have we have 1 there. Okay, then we have l. So our L is the last term, which is 101. Okay, so now for us to be able to to find this n, so we are going to bring in another formula, which is which is called the nth term formula. So it can be in some material or in some textbooks. You can see something like this, Tn, which is the nth term, or we say is L. L is our last term, equals to a plus bracket n minus 1 d. Okay, so that's the formula for finding the nth term of what, of arithmetic of an arithmetic progression. Okay, so looking at what we have here now, we want to find n. So our last term is 101, so we have 101 equal to a, which is 1, so 1, okay, then plus bracket what, n minus 1, d. So our d, which is the common difference, and I told you previously that for you to get the common difference, we have to do a subtraction between the first term and the second term, or the second term and the third term. So, and the difference when you do that must be common. So let's look at it. So let's put something down here, d. So let's do this. 3 minus 1, that's 2. 5 minus 3, that's also 2, which means the common difference is what, is 2. So let's substitute it here, which is what, 2. So let's open this up. So this is 101 equals to what, 1 plus 2 times n, that's 2n, 2 times minus n, that's minus 2. So let's collect like times. So we'll be having 101 minus 1, when it comes to plus 2, equals to what, 2n. Okay, so when we do this, 101 minus 1, that's 100, plus 2, that's 102, equals to what, 2n. So let's divide both sides. So we are looking for n, so divide both sides by the coefficient of what, n, which is 2. Divide both sides by 2. So that will be giving us 102 divided by 2 equals to 2n divided by 2. So n equals to, divide this, 51. So n equals to what, 51. Okay, so it means the number of terms is equal to what, is equal to 51. So if you've enjoyed this question up to this level, don't forget to like, don't forget to subscribe, and also what, share this video to your younger ones who are preparing for an examination, or for your younger ones who are also who are very very good, who want to learn uh, mathematics, and so this can be a kind of a motivation for them. So don't forget to like, don't forget to share this video, and also subscribe to the channel. Okay, so the number of terms here is what, is 51. Okay, so let's now find what we want to look for. Okay, um okay, so we are going to be using this formula. So we can use any of the formula, since we already have our n. But for this, I'm going to make use of what, of this. So which means if I make use of this, so my s now, Sn, I already know what my n is, so I'll just put it here. Ns 51 equal to, what's my n? So it's 51 over 2. Then my a, which is my first term, is what, is 1, plus my last term, which is what, 101. So this will mean that what, S51 equals to 51 divided by 2 times 101 plus 1, so that will be 102. So divide, so this will give us 51. So 51 times 51, if you punch your calculator, that should be giving you 2601. So it means that the sum of the arithmetic progression for these values here is what, 2601. Okay, so that's the answer to it. So if you've enjoyed this tutorial question, don't forget to like, don't forget to subscribe, and also very very important, share this video to your younger ones, or to a friend that you think needs it. Have a good day, and bye bye.